Paris, France. They're just there. They're all like, take your euro to go in. Okay, leave. I think you should do my business. You gotta leave. Like there's no room.
I know. I know, just a couple more inches. Oh, I'm sorry, centimeters.
It gets worse.
Welcome back to the sessions. Quick reminder about the feedback. Don't forget to get the feedback.
Be nice.
At 6 o'clock, there will be the lightning talks if you want to participate. I don't know if you can still propose topics, but go there and find out. In the meanwhile, let me introduce Luis, who will tell us how to better manage our Gluster clusters.
How you doing? My name is Luis Pabon, and I work for Red Hat Storage. I'm a principal engineer there. And this is actually a picture that my sister sent me. I guess somebody saw me and they created me in the Big Hero 6 movie. So I'm there in the Big Hero 6 movie and I'm at a conference, just like this. Except I'm a little younger there, so I don't have as much white. So let's take a little history to understand what is the need for Heketi and why it was created. When we first started with GlusterFS, we wanted to integrate it with OpenStack Manila. And if you know what Manila is, it's trying to provide file shares as a service. So you have Cinder, for example, in OpenStack, provides block. You have Swift, it provides an object. So the new project on Manila, I wanted to provide file. And to do that, we wanted to be able to use GlusterFS as a backend storage for Manila. So that came with some new areas and new models that GlusterFS needed to adhere to. And that's where Project Heketi was created. So before we go ahead and start talking about Heketi, what it does and what it tries to solve, let's first try to understand what GlusterFS is and how it's created. How do you go ahead and create a volume? First, what is GlusterFS? Does anybody doesn't know what GlusterFS is? Yeah, get out of here. So, anybody else? So, as you probably know, GlusterFS is a distributed, reliable file system that you can access from multiple protocols. So, you can access it from NFS, from Samba, you can access it from Object, from Swift, and you can access it over Fuse, and also from API format. So, at its unit of usage is really a volume. So, when you want to go ahead and access GlusterFS, the very first thing you have to think about is the volume. You have to create this entity out of your storage, and that's how you end up using GlusterFS. But then, how do you create a volume? So, the very first thing you have to do when you want to start using GlusterFS is decide what systems you want to use for. Once you decide the systems, you decide what storage in that system you would like to use. Once you decide that, then you start dividing it. You start creating, taking one system and joining it with another, what's called peer probing, and then extending your trusted pool. So now 2 nodes become a trusted pool, and as you add more and more nodes with storage, to become as a larger trusted pool. So then you have not only the storage, you have to decide what to use, but then you have to also set up a file system on that storage. And let me explain why. So, before I go to the next one, GlusterFS has 3 models. So it has the volume, and a volume is a collection of bricks. And each brick, when I first started at GlusterFS at Red Hat Storage, and I asked actually this question, what is GlusterFS and how you set it up? And they said, well, it's a volume, and they set up bricks. And I said, well, hold on a second. What is a brick? And they said, well, it's a directory. But they just call it that. But anyway, it's kind of confusing, but a brick is really just a directory, and many bricks, you can join them together to become a volume. Now, depending on how many bricks you need, it all is dependent on the durability model that you choose. For example, you could say, I want replica 2, I want EC, and those type of requirements on your volume determine the number of bricks that you need to actually create it. So for example, here we have 3 nodes, and those 3 nodes we created, each one has 3 directories. And those 3 directories may be on a RAID, they could be on a disk. It depends on how you want to decide how to actually create that storage. You then, to create the volume, you have to almost like unify these, but you create a volume out of these many bricks that you have actually created across the many systems. Now I want to point out here that once you create the volume, here we have set up the durability model of replica 2. And then in this model we have 6 bricks. Now it's really interesting to see here also that we have chosen that server 1, this brick, its replica is the one after that. And second, it's the second brick, and its replica is the one after that. So you have to be very careful how you organize these in the command line. Okay? Lastly, you then start the volume, and then you can go ahead and mount it. And when you mount that volume over GlusterFS, then you get the nice unified storage of the volume. But there's an issue here. So anybody can tell me what the issue is with this model in the cloud? Yes, exactly. Somebody typed this, and that is not scalable. This only works at the model of the number of requests per second. So for example, if you get 1 request per week to create a volume, this is great. And GlusterFS works great at the NAS model, where you can create a massive amount of storage. And the volume becomes available for a long time. But in the cloud, you got volumes that are small. You got volumes that have so much lifetime. They come in, they come out. Each one of us has different durability models. Some of us have EC models, some of us have replica 3, some 2. And we want those volumes now, as soon as I press the button for the request. So we need a new way to be able to achieve this. So this is the face when you look at when somebody has to type that for every time. But we need a new way to go ahead and achieve this, and that is what Heketi is trying to bring in. So Heketi itself is a REST service that has an intelligent algorithm inside depending on the topology of your data center. So it takes that information that you provide for your data center, and then it goes ahead and creates many volumes according to the requests that are coming in. And again, Heketi is not really supposed to be used by administrators and such. It's supposed to be a service for something that provides multi-tenancy. Something like Kubernetes, something like OpenStack Manila, or any other system that maybe a hospital or something else that is local only for a private cloud. This is the architecture of Heketi today. It is HTTP framework on the top. It has a middleware where we can add more services in the future, but today it only has the authentication. It can go ahead and has a database to be able to track all your storage across the entire data center. And then it has these things at the bottom they're really plugin models. So today, Heketi is very young in its software, so we just have enough information there to be able to have the allocator. So here's the allocator that decides where to put the bricks in what system, in what node, in what zone, and we'll go into zones in a second. But it's one algorithm. We can probably come up with more efficient ones in the future, so that we just plug some in there. And here, now we have an SSH executor, which means that Heketi wants actually to go into a system and set up commands in that system. Today, we just SSH in there, but there's nothing in the future that says we can have a REST system, a REST interface to something else, or we could have Ansible there, or something else. So let's take a look at the workflow. Let's say, for example, you have a data center, and you want to start using Heketi for it. So the very first thing you did before with GlusterFS is that you rolled in your racks of service, and you have your storage, and you started deciding what to use, and you started deciding how to set up your storage. Maybe you did RAID or not, and then you have to set up your file systems and such. But let's go now in the Heketi model. You again roll in your storage, your racks, and that's it. That you have to install Linux, of course, on it, and then set up a cluster, but that's pretty much it. The next thing you say is, I need to tell Heketi about my new storage systems. First, what I'm going to do is I'm going to create a cluster. A cluster is just a collection of nodes. And on that cluster that I created, this entity, I'm going to add my first node to it. So I add a node. But now we have more information that we're giving it than we did before. We're not just adding a node, but we're saying this node is on this zone, this failure domain. So as we start adding more nodes, we start dividing the failure domains. So before, in GlusterFS, you had to think about that information. You had to understand where to place the brick, make sure its replica was not in the same failure domain as your other replicas. But in this model, Heketi will do this for you. You just have to explain this rack is sharing the same switch or the same power supply, and this other rack is sharing the same switch. So that we have two different zones here and one cluster. And as we add more and more nodes, Heketi itself will start adding creating the trusted storage pool. My goodness. Next thing we need to do with Heketi is we added the nodes, we defined the zones. Next, we start adding the storage. So on that node, for example, we add each one of these disks or devices. They could be RAID devices. So in other words, we're telling Heketi, this is our topology of our system. Not only can Heketi do one cluster, so when people think of GlusterFS, they always normally think of one cluster, one trusted pool. I'm not stop saying that. But Heketi can handle any number of clusters. So that means now, before you thought, you maybe had some constraints on the amount of GlusterFS, how large you could go. But instead of thinking just one massive volume, you could think of many, many endless number of volumes. Okay? So now let's take just a normal request to create a volume. What's the very first thing that Heketi does? It goes ahead and it has an algorithm to determine where am I first, how many bricks am I going to use to satisfy this request. It calculates all of that. Then it says, all right, let me go ahead and see which one of the devices can satisfy this brick that I need to place on there. So it goes ahead looking in the topology, looking for devices that it can use. So as you can see here, in this replica 2 example, we have a device chosen on zone 1 and a different device chosen on zone 2, and that's its replica. And it did that automatically. And then if this is a distributed volume, then it will go ahead and create the other two, and one in one zone and one in the other. The really cool thing about Heketi 2 is you can say, when you create the volume, the request to create it, you don't have to specify the cluster, and it will just find a volume somewhere for you. Or you can specify the cluster specifically. I say, I want a cluster on that, I want a volume on that cluster. Maybe the request is coming from somebody who's paying more for example, SSD, or paying less, you just say that. And then, or you can say, I want it from this subset of clusters. Okay, maybe you have many clusters of SSD or many clusters of SATA. All right. So what other features does it support? It supports, you can say to Heketi, create a replica 3, create EC, create in this. So it's very easy for Heketi to do this all for you. And it's all available from the API. And also it supports volume expansion, which is kind of neat because as you create a volume, you may need to increase the amount of storage that you require. And it will go ahead looking again for new bricks to satisfy that request. So, yeah?
How is it determining that which library type is being used?
On the request, the requester asks for that. I want a volume of replica 3. The requester asked. In the API request, in the JSON, you say you can specify durability type, and there is none, which means there's nothing. There's just distributed. There's replica style, or there's EC. So you define that in the request.
How does it know the storage devices?
How does it know the storage devices? Going back here, the administrator, when he first rolls in those machines, the very first thing he does, or her, is to tell Heketi all the topology information. That is failure domain, nodes, devices. That's all you need to tell. And then Heketi takes care of the rest.
That may be difficult, right? If you have 60, 100 or more than 100 devices in a node.
Yeah.
Listing out all these, telling Heketi all those devices may be difficult, right?
No, it's not difficult because normally these machines come like already set up, and all you have to do is Heketi send. It's just, remember, it's not from the command line. This is a service. So some software will tell Heketi of all these devices.
That I know some REST API to tell Heketi that these are the
Yes.
devices.
And it's completely concurrent, acceptable in parallel. So you can tell Heketi yes with 100 requests at a time. Yeah.
Remember the storage devices. 60 devices means I have to enter 60 device names. How do you, maybe you can flow the demo. You're going to flow the demo, right?
Yes. So I guess you're ready for the demo. All right. Okay, so let's go to the demo here. And this demo is available on the Heketi website. So you can go ahead and try it out yourself. It is based on Vagrant and Ansible. So I already ran the Ansible and Vagrant, so I haven't done anything else. So from this point on, it's just following the instructions that are on the website. Okay? And I'm sure we'll go in, answer questions. You can ask me. We can type other things and things like that. But here we go. So the very first thing we're going to do is enable the Heketi service. So Heketi, actually I'm going to talk about this in a little bit, but Heketi is available in Fedora, it's available on EPEL, it's going to be available on CentOS Storage SIG, and it's available also as a container. So, and it's available in RHS as a tech preview. Yeah. So, this is Vagrant, SSH, it's available in RHS.
You said it's an email.
It's an EPEL. Yes. Yes. So the very first thing we're going to do here is look at the demo. And if I can find it, here we go. So the very first thing we're going to do is copy a configuration file. So you're here, and Heketi uses, of course, Heketi uses a configuration file in JSON, and describes what port to listen to and such, and what authentication and what user to use. And then we have at the bottom some information that it's needed to be able to SSH. Just like if you use Ansible and any other system, you need to provide your private key for all your systems. And the requirement right now is to have the same public key and private key for all your systems that you want to manage. So here we do sc copy heketi.json to /etc heketi. All right, next step, we're going to start our service. Su service start. So there it is. It is now running on this system. Okay? So now we can have some fun and get some information from it. Here's a REST client available on Firefox. You can try it out, but what we'll do is we'll say HTTP. We'll get all the clusters on it. Oop. Looks like there's an issue with the networking. All right, I'll do it from the side. So let's go back here. So next step we're going to do is use the command line client. Now Heketi provides a command line client as an example. So when you use the command line client, you say, oh man, this is terrible. It's so specific to the API. But that's what it's supposed to do. That's its goal. It's a demo of how the API can be used. And hopefully services will be able to combine those APIs into one call that is more humanly usable. So here we have Heketi CLI, and it's available. You can talk about the clusters. We can talk about nodes. So the very first thing we're going to do is we're going to say, give me the cluster information. Look at me cluster list. And there's no clusters, because there's nothing. We haven't done anything yet. There's no topology yet. And so, Ramesh, I'm going to answer your question now. And this is where services really help. For example, I did add one service call to Heketi client because it could take some time for me to type every device in the system. And I called it to load the topology. And what that is a JSON file that has the entire topology of my cluster available. Okay, so we have many nodes. Each node has an IP address and has some devices. It describes what zone that is on. Okay? So we'll just run this. We'll say Heketi CLI load H. And we say JSON topology delivered. And there it goes. So Heketi, now this is slowed down. I don't have to do one at a time. I could have just sent all the devices to it and it would have done all in parallel. But I think there's a problem here with my Vagrant and standby of the machine. But 1 second. So this is slowed down. So what it's going right now is creating the nodes. It went to the devices and it went ahead and created set up the storage for usage. And I probably can't ping 192.168.10.101. Yep, that's what I thought.
So when it says adding device, you mentioned on the slide LVM. Does it provision it as physical volumes, and on top of it, it does LVM, and each brick will be an LVM?
A thin pool, and then there'll be a small LV on top of that. Yep. So let me go back out of this because it seems to, when you go in standby lib, it seems like.
Back to my question.
Yeah.
Instead of asking the user to specify the topology here.
Hold on a second. What? Oh, just halt it. Halt it. You see if that works. All right. So what's your question?
Here user has to specify the topology, right? Like this, all these things. The topology has to be entered by the user manually through REST API or somewhere.
The what?
The topology of the
The topology of the system.
Instead, you could discover using the
That's what I'm saying. The service takes care of that. The service who calls Heketi can either have it done by human person.
So
You could discover. What I'm saying is that the service can discover that information. However it gets it, it then supplies it to Heketi.
Why not Heketi discovering those results?
Because
Because it has communication with the node, right?
I'll explain why. Every data center in every place is different, and the services understand those data centers. So the services themselves understand what's going on. Heketi doesn't know, right? So if the services can provide that information, however they access it, then that's probably the right model. All right, so let me try this again. So let me say shut down. All right, remove. Ugh. All right, let's try this again. Sweet. Of course. There it goes. You know, live demos always are terrible. Let me go back with the recording I have. Where is it? Anti-access, there we go. What?
Do you have DLC or something?
No, that's all good. I'll take care of it from the web. You know, when things happen, you know. All right, here we go. It's right here. Hopefully I have Wi-Fi now. Come on. There it comes.
There's a cable to attach to the actual network.
Oh, I don't have Ethernet port, so I have Wi-Fi, or I should. Wow.
Just open the video file and don't triple it.
Oh, yeah, you're right. Thank you. Ugh. Thank you. All right, so we'll do the same thing. We set up the system. Here it is running. We'll go into storage 0. We'll go and load the information, the storage, the topology. Okay, and then on the back side, while I'm showing the topology is coming up, I'm showing the logs of it going actually into the systems and setting them up. So once the topology is set, I'm trying to get rid of that bar at the bottom. Sorry. Then it goes. We can go ahead and say cluster info. We should be able to get information. Now we can get information on a specific system, and everything in Heketi is done with UUID. So every device, every node, every cluster has a different UUID. So everything can be referenced uniquely. So here we have the node information, and we can see all the devices that are available in that system. We also can get an IP address and what cluster it belongs to. So here we have, we're going to start looking at the volume information, and then we can start looking at the create information in a second, and we can look at the help file inside of it. So in create, as you can see from the example here, we have a lot of options of what you can actually request. You can request, I think somebody pointed out durability type, but you can have durability type. You can use EC. You can also specify how much storage do you want for snapshots in this volume. For example, if you don't want snapshots at all, or you want a lot of room for your snapshots. So let's see here. We're trying to create a 1 terabyte size volume. It goes ahead with looking at the logs on the backside, and Heketi has decided already what systems and what device it's going to use, and it went ahead and started setting them up with LVs, thin pools, make FS, all that stuff. It joined them all into one volume for you, and now we can go to the client, and we can see that there's nothing mounted. We go ahead and mount that node and UUID. And
so the MKFS happens when you create a volume,
yes,
or when you provision the machine?
when you create the volume. It happens on demand.
Yeah, because you need the size.
Exactly right.
And what is the idea? You're creating the VM volume, and after that you create a logical group for each brick of the cluster?
Yes. So you create an LV for every brick. And then if, actually, you first create a thin pool on top of FVG, depending, the thin pool size depending of the amount of LV that's needed for the brick, and the rest needed for snapshots. So then, once it does that, then it does make a fast and set up the entire brick. Entire cluster volume.
One question. Is that in real time?
This is not in real time. Some parts were accelerated.
I was wondering, I was...
You had to ask that. That looked cool. Yeah, I know. Some parts were accelerated. And actually, yeah, I try to keep it less than 5 minutes. So here, then, once we have a volume, then we have the ability to expand the volume. So we can say, we give it the UID of the volume, and we then describe how much more space we want. This is really cool. I'm surprised that sometimes QEMU has issues with networking when the laptop goes in standby, but I wanted to show you that you can create a volume, have it mounted, go back to Heketi, expand the volume, and watch it on the mounted system, actually the size increase of it. So it's pretty nice. So here we have a volume expansion. And we go back to the client. In a little bit, you can see from the volume info that it's expanded. We go back to the client and mount the system. And there it is at 1.2 terabytes. We added 200 gigs to it. So now we go mount it. The last thing we're going to do is destroy it. So again, as a service, you have to be able to create, expand, destroy. Those are the three things. So I can't get rid of this bar in the bottom, but I just typed Heketi volume destroy in the UID, and it goes ahead to, first it stops the volume, it goes ahead and deletes all the LVs, and then puts everything back so that it deallocates all that storage available to somebody else. Okay? No, we're not watching it again. Okay? So let's go back here. And like I mentioned before, this is available right now. You can try it out. You can try it as a container really easily. So when I showed you before, the architecture has what's called different executors to be able to send information to a system. But it also has something called a mock executor. So when you download the container, you'll first, actually when you download any of these, it's first set up with a mock executor, meaning you can create clusters, you can create nodes. It doesn't send information anywhere, but you can check out and try out the API. Lastly, what's next for the project? So it's still kind of in a baby. We started in about June, July. And the next thing we have to do is conflict resolution, which is kind of a simple thing, but you just haven't had time. It's when you add a node and you add the same node again. It should know that it already has it, or the same disk. But it wasn't as much a big deal because this is not a human interface, this is for services. But we still need to make sure we have that feature. The really cool features later are what to do when something fails. So for example, let's say you have your many volumes all over, and then one of the nodes die. Heketi gets informed, node whatever ID died. It can go ahead, allocate new bricks automatically, update all the volumes, and everybody will be fine. So even if you wanted to say, I want to take this, I want to upgrade the amount of RAM on this system, so you can just tell Heketi, this failed, so it pulls everything away from it, grab the system, putting a new RAM, put it in, and then tell it again, and it can use it again. And lastly, I know there's a project called GlusterFS 4.0, and in that project there will be a new REST interface to GlusterD. Right now we have to SSH into the system to communicate with Gluster, but it would be great to have this REST interface with Heketi. Okay? That's all I have. And this is it. If all these slides are available up there on that link. Thank you. Any questions?
Is there any plan to add some discovery tool based on a rule example?
For creating a topology?
Yeah.
Yeah, again, if you create your own program for your own discovery tool, maybe you could use UDP, for example, in your systems to find out new nodes. Maybe you have your own software that when you plug in, automatically sends a UDP packet or registers with some registration system. You can use that information to Heketi. But Heketi itself, I'm trying to keep it very simple because every different data center, it has a different requirements on discovery.
Usually often you have, every case is different, but in the same organization, often you try to replicate the same configuration over and over and over again.
Yeah.
If you can say, example, all the servers are in this range, are in this zone,
Yeah.
and we're able to say, on what they know, so has this IP,
Yeah.
so I'm in this zone, so I really know how this is.
I guess that's one of the things that we need to whiteboard to understand how that can be done.
Do you know of any existing such services that already try to find out, to discover through the network, like you said?
Do I know any such services to discover? It depends on the size of the data center. So there's, you can use, I think it's SMP for MIP for discovery, that's one way. But I know a very easy one to do for small data centers is UDP broadcast. It's very simple.
But I'm talking integrated with this tool.
Yes.
It's something that just goes on and discovers, creates a JSON file and passes over.
You know what we really need is to be able to use some discovery service with a cloud model. So if I can talk to the cloud and find out the nodes, I'll find out information.
I was just wondering if you know one that exists already or everybody has
I
to
don't
find
know.
one.
So we can talk to that guy back there and find out. Yeah. Right then.
Well, I just have a question. Do you think that GlusterFS is architecturally robust enough to be elastic in the cloud itself? I mean,
You're putting me on the spot.
no, I mean, it's a fair, I mean,
I know.
I really don't know the answer.
That's a good question. So the question is, do I think that GlusterFS is robust enough to be able to deploy in the cloud in this model, creating many, many, many volumes that are small and creating many volumes at a time concurrently and changing the sizes and such? I do not know how to answer that. I would have to, let me put it this way. This is a new, storage as a service is a new model for GlusterFS, and it would need to be investigated to see how well it can handle it. I don't know how well it can handle it. I don't know how bad it can handle it. But I think it's an unknown that we need to answer. Yeah, Shava?
Once you start creating your volumes and everything, you're building a lot of intelligence into the Heketi database.
Mm-hmm.
What's the technique for backing up that data or failing over the data? I mean, could you store the database in the cluster itself so that if you lose your Heketi server, you don't...
So that's a great question, actually. Let me go back. Here. Today, Heketi uses an internal Go. Heketi is written in Go, and it uses a database called BoltDB, which is a really good database for simple applications. It is a key value transactional database, copy on write B-tree kind of thing, which works really well when you're trying to do things and you're trying to back out of them. So you could do something, and you could realize that you fail halfway, and you fail that transaction, your database still stays clean. So you could do many things at a time on an entire transaction. Now, it is a single point of failure. If the database fails, you will lose all of that data. Today, we have to put that BoltDB on something that is safe, but we can definitely change that in the future. Yeah.
Very much related to that, do you have a way of inputting existing clustered environments into this database?
No. We cannot import, and that for sure, we cannot import existing Gluster environments to the system because existing Gluster environments have an infinite number of combinations and permutations of how they were created. So I'm talking about the hardware, the disk, the storage, not the volume itself. So we would have to go into the volume and find out how the disk was created and find out, one of the things that Heketi does, for example, is to make sure that everything's aligned when it creates the file system. So there's a lot of things that it would need to do before it actually can take over an existing system. So I'm not saying it's impossible, but it would be really hard. So.
Do you have any idea about the conflict detections, or is only the future?
I'm sorry.
Because on the last slide you showed that you have planned conflict detection.
Yeah, conflict detection, yes.
Yeah, do you have any plan already, or is some future?
No. It's in the plan. It's actually the next thing I'm going to do.
Okay.
Yeah, absolutely. That needs to be done.
And there is an idea that you have, turn off some Gluster servers for some maintenance, or in any cases that you mentioned, if something fails, you create the other brick,
Yes.
and the last one that you turn off goes away.
That again is an idea.
Okay.
It's not something that we have set in stone, and but it's definitely we can have talk about. And lastly, everything's available here on GitHub. If you have any questions, you can go to Heketi on GitHub, and there's a channel there for Gitter, and you can ask all the questions you want on there that people can see, and I'll be able to answer. All right? Thank you very much.
Last reminder for lightning talks, last chance to go and
Thank you
sign
for the
up
great presentation. Could you please upload me slides?
after this break.
What's it? They're not in PDF format.
Yeah.
They're in Go, and they're only available online.
Okay, so you can export it.
Yeah, they're only available there. Let me help you with that in a second.
Okay.
Yeah, hold on. This is yours.
Right.
I'm talking about Ganesha, yes.
Okay, I'm not leaving. I'm sorry.
All right.
Dude, one small comment. You're using the flag library, aren't you?
The what?
The flag library,
The what, library?
the first CLI
Oh,
parsing.
yeah.
You gotta rip that out.
That's the Go flag,
Yeah, you
library.
got garbage. It's complete garbage.
Oh, you do what? You want me to just let go?
You
Why?
have to get
Because
rid
the
of
dash and thing like that?
Yeah, you have to use a proper library, like
Okay.
Code
It's what's come
Gangsta
with Go.
CLI. I know it's crap. No one uses it.
Oh, really?
Yeah, it's crap. Right? You know what I'm talking about? This single dash thing.
Yeah. That's
I
what Go chose.
That's constant?
It's garbage.
Yeah, I want to say something about
Yeah.
it. That's JSON, right?
Yeah, no.
No, it's Go language.
It's a Golang thing. The flag, it is native for their like simple tools.
Yeah,
and it's,
yeah, yeah.
They have to have one,
Yeah.
but no one uses it. Everyone uses like Code Gangsta
Okay.
is one that I'm using, but
Okay.
there's another one that's also just as good.
I'm sure. I'll use whatever. I'll change it.
Not like whoosh.
No, man, I'll change it. It's easy.
I'm just like telling you a small thing. No one, someone has to tell you these things.
Yeah.
I don't know. You could. I'll